Alright, so welcome to IB Math Studies first video. We got some pre-class notes for reviewing quadratics, so hopefully you guys have seen this before, but we're basically going to go over factoring polynomials and foiling polynomials. So anytime we see the phrase expand and simplify, we're going to use what you might have seen as the FOIL method. Or another way to think of it is we're basically just distributing both of the terms in the first parentheses to the terms in the second. Right? So again, so if we were distributing, we're going to multiply the x to both terms, right? So x times x, x squared. X times 7, 7x. And then we're going to do the same thing with the 3. So 3 times x. 3x, 3 times 7, 21. Alright, and so from here, right, all we're going to do is clean it up. So my like terms, 7x, 3x would give me 10x, and then we're done. Alright, so again, pretty straightforward. Hopefully you guys remember this from algebra. I got a couple more for you to do on your own. So the other two, again, you're going to work those out on your own, and we'll go over them in class next time. All right, so we notice here, same thing, expand and simplify. Difference now is that the constant term in each binomial is the same, except for the signs alternate. One is positive, one is negative. Right, so this is going to be called the difference of squares. So basically we're doing the same thing we just did, right? X times x, x squared, x times 2. It's going to be 2x, right? So minus 2x plus 2x minus 4. So what we'll notice is that the middle terms cross out. And this will happen every time that we get difference of squares. So oftentimes we will see the formula written like so. Right, again, we got a couple examples for you to work on your own. All right. Looks like it printed weird when I printed it out. So these or for you to work. All right, so the next one. X plus 3 squared. Right? So first thing to remember, the squared, the exponent, does not distribute. Right? So I cannot say that it equals to x squared plus 9. That does not work. Right? Remember that. When you square something, you're basically just multiplying it to itself. So if I want to expand this out, I'm going to write multiple copies of the same thing and then multiply it out. So just like before, the x goes to both terms, the 3 goes to both terms, and then we simplify. So we should get x squared plus 6x plus 9. next example, we're going to take a binomial and multiply it to a trinomial. Right? In other words, we're taking a parentheses with 2 terms, multiplying it to one with 3 terms. But the distribution still works exactly the same way. Right? So the x goes to all 3, and then the 3 distributes to all 3 terms. So if we look at it, right, x times x squared is going to give us x cubed. X times x is going to give us x squared. 2 times x is going to give us 2x. Now I notice I'm going to get a bunch of extra stuff. It's going to be a really long string. So what I'm going to do now is, instead of going all the way across, what I'm going to do is stack the second set underneath the first for organization. Right? So 3 times x gives me 3x squared. 3 times x gives me 3x. 3 times 2 gives me 6. And so what I have now is all of the common terms lined up so that I can just add straight down, right? So x cubed doesn't add with anything. But if I take an x squared and a 3x squared, it gives me 4x squared. I take a 2x and a 3x, and it gives me 5x. 6 comes down, and we have our answer. All right. A couple of examples for you. What we're going to do next is look at cubing polynomial. Right? So if we said squaring means you multiply it by itself twice, cubing means we're going to do it 3 times. So I'm going to suggest sort of combining the methods we did for the last 2 examples. So the first thing we're going to do is multiply 2 of the parentheses together, and then take that answer and multiply it by the third. Right? So if I distribute the second 2 parentheses are going to give me x squared plus 2x plus 1. Because again, that's x times x to get x squared, x times 1 to get x, 1 times x to get x, which would add to 2x, and then 1 times 1 gets me 1. So to finish it off, I'm going to take the x plus 1 that I didn't do anything with and multiply it to what I got when I put the second 2 together. So this guy should look exactly like the example we just did. So if I distribute the x, I should get x cubed plus 2x squared plus x. Distributing a 1, right, that's just going to give us the same thing we just had. So an x squared plus a 2x plus 1. And then I'm going to add down. All right. A couple more examples for you. All right, so the last thing, or the next thing rather, factorizing. So the IB calls it factorizing. In US textbooks, you will see it simply referred to as factoring, right? So if you did this in Algebra 1, we called it factoring. Same thing. If we remember from class, right, we said factors are numbers that multiply to make other numbers. So for factoring a polynomial, we're just going to figure out another set of binomials that would multiply to make the polynomial we have. Right, so if you remember, we're going to look at the factors of the first and last term. So in this case, the first term is 1, so we can ignore it. We think of things that multiply to 6, right? That's 1 and 6, 2 and 3. I need things that add to 5 because that's what's in the middle. It's 2 plus 3 equals to 5. So if I write out my parentheses, I know that x times x gives me x squared. I know that 2 times 3 gives me 6. I need a positive 6 and a positive 5, so everything's got to be positive. Another way to factor is to look for a common multiple. So I notice in this one, both terms have an x. So that means I can factor an x to the front. If I divide an x from 3x squared, that leaves me with 3x. And if I divide the x from 5x, I'm left with 5. I put the dot there to represent multiplication. You probably don't need to do that on yours, but it sort of helps to not be confused, not to think that's written like a function. All right, so if we remember, we said that if I multiply two binomials where the terms match, but the only difference is the plus minus in the middle, that middle term cancels out, right? In other words, we said that a plus b and a minus b multiply to a squared minus b squared. If I look at x squared minus 4 and I want to split it into factors, I know there's nothing common between the x squared and the 4, but I know that x and x will multiply to x squared. If I'm thinking, how do I factor this? I know the factors of 4 are, 1 and 4, or 2 and 2. And I know that if I take 2 minus 2, it equals 0. So, put a positive 2 here, negative 2 here. We have just worked out the formula for difference of squares. So hopefully we see how that matches with what we had on the previous examples. All right, last example. What do we do when that first term is not a 1? This is going to work the same way. Basically what we're going to do is take the factors of the first and last term. So 2 times 5, I'm going to multiply them together. 2 times 5 equals 10. I'm looking for something that will multiply to 10 with a difference of 9, because 9 is the middle term. So if I take 1 and 10, I can subtract those to get a negative 9. So when I split up my fractions, right, I know that x and x will give me x squared. I know I said that 10 and 1 will give me 9. But since I'm missing a 2, divide both by 2. 10 divided by 2 is 5. I notice 1/2, it doesn't work because my original guide didn't have any fractions. So all I'm going to do is slide the 2 to the x. And that is how we factor. Have a good evening.